Hello. Hi. A very good morning to all of you who have joined for this session. I am Rehna BV, Project Officer, Energy Efficient Building Cell at EMC Kerala. EEB cell has been functioning at EMC Kerala to facilitate the implementation of Energy Conservation Building Code 2017 and Ekoniva Samhita in Kerala. ECBC is one of the flagship programs of Bureau of Energy Efficiency to improve energy efficiency in commercial and residential sector and decarbonize the built environment. Through this two-day training program, we intend to impart the approach of integrative design in buildings. Further, I invite Mr. Dinesh Kumar, who is the Head of Energy Conservation in Buildings, Outreach Programs, Standards and Labeling, and Small Hydel Development at Energy Management Center, Kerala, for the introductory remarks.
Thank you, Rehna. A very warm welcome to one and all. In fact, I would say I need not explain much on what an ECBC or an ECBC, what is its relevance and all, because we are all baptized into the system much earlier, and this being an integrative design related training program with an intensive, more in-depth discussions. I believe everyone will be keen and interested in getting into the training part of this thing, and more than on a small scale discussions or small speeches and all. Therefore, I directly invite Mr. Arpan Pal, who will be giving the training programs for you today. Next day you have, the second day you have with us Mr. Kumar Viplav, who will be giving the training, and Mr. Arpanpal and Mr. Kumar Viplav both are known to you. Therefore, I don't want to explain who they are and what is their capability, because they had been the best teachers available for us for this PEEE training programs, and most of us who have joined into this program are, I believe, PEEs or the first stage training complete peoples. Therefore, I am just transferring over the mic to Mr. Anpal. Thank you, and wish you all a good informative training session. In between, I will also like to inform that there will be a session, part of the session, which will be directly focused on the mistakes which had been seen in the submissions given by the already trained people, which submissions given to EMC. There are small issues which could have been avoided. This training program will also concentrate on that part. Therefore, you are requested to have a keen concentration on this program, and thank you very much.
Thank you, sir. So, I welcome Mr. Arpanpal for the training. Sir, over to you, sir.
Thank you so much, Mr. Dinesh and Rehna. It's been a privilege to again present to Kerala ECBC and to try to give and share whatever knowledge I have of ECBC to all of you, and thank you for taking the time off to attend this session. And as Mr. Dinesh said, that I believe a lot of people have joined, have attended the previous trainings, and hence are aware of what ECBC is, and then some aspects of energy simulation, and then what are the various design aspects that should be considered while designing and constructing ECBC compliant building. This will be, if I'm not wrong, this will be my third or fourth year training session with ECBC Kerala. And again, I want to thank the EMC cell for giving me this opportunity again. So thank you so much. So as Mr. Dinesh said, that we would be going over to the administrative aspects of ECBC and then what all are required when you submit for plan approvals and your various approvals. So the second half, so I believe the next session of this will be more towards that. I mean, what all documentation you have to fill in, which all departments you have to submit those documentation to see, and all those things. So I believe we'll be having a good session. And as you are aware of ECBC, I would like to be the session as much interactive as I could make. I will try that from my side. But yes, to make this but to make the most out of these 2 days of training sessions, I believe your participation, your involvement, your enthusiasm is the most important, and I would not be able to make this more engaging. But so I'm looking forward to this. I'm sure that based on my previous experiences on this, those sessions have been for me as a trainer, because a lot I mean, especially the equest exercise and the requests and the questions, I mean, those make your trainer also more you're prepared for the year next one. It is also a learning experience for me as it is here for you. So I think the first session, so I'll just give a brief about what the day will look like. So the first session would be more about what ECBC is and the structures and things, and a brief introduction about the Kerala ECBC. So I'll be sharing my screen, and I'll be sharing the Gazette K SECBC, which I think has been shared with you all. So and then we can go it to step by step and to see what are the various ways of ECBC compliance and stuff like that. Okay, so let me share my screen, uh, and um, and we'll take you forward from there. Okay, so let me know if you can see my screen.
Sir, it's visible. Can you make it as a slideshow?
I will make it. I mean, this is not the presentation. This is the PDF, right? So I'll make it. So this is basically the presentation. You want me to make this as a slideshow?
Ah, yes, sir.
Okay, the other screens became slideshow, not this one. Okay, let me share another screen then. In that case, I believe it. Let me know if the full screen you can see as the presentation.
Yes, sir. We can say participants on the right hand side on the bottom, you can see the zoom in and zoom out. You can adjust there according to your convenience.
Okay, great. So again, on ECBC, which stands for the Energy Conservation Building Code. So we'll start with some basic aspects about the ECBC and some statistics of what the world energy scenario uh, 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 is. Yeah. So the purpose of the ECBC code is to provide the minimum requirements for energy efficient design and construction of your building, right? So ECBC lays the minimum laws or the minimum requirements that a building should have to make energy conservation, to make it energy efficient. So yeah, that is the main purpose of the code. And the code also provides two additional sets of incremental requirements to achieve. So in previous ECBC versions, I mean in 2000, sorry, in year 2017, what they have done, apart from having ECBC, they are saying that they have given two more set of achievements, that is ECBC Plus and Super ECBC. So they have added these two additional set of requirements, which of course, if any developer or any builder wants to achieve, they can achieve. So along with the minimum requirements, ECBC 2017 paves the way for those two additional set of requirements as well. Now, currently, I mean, it is estimated that India will add almost 1 billion square meter of new commercial spaces by 2030. Now, if this is the case, just imagine the amount of energy requirement the real estate and the sector will be taking, right? And already given like India is mostly coal, well, or a thermal power plant based electricity system. Although we have huge amount of renewables, we do have, but in terms of the base load, that is taken care by the conventional coal thermal power plant. So imagine if we add 1 billion meter square of new commercial spaces by 2030, just imagine the amount of stress that will put on the grid. And of course, although India has a good coal reserve, we can go on, but still there are issues of a climate change because burning coal will again create CO2 that will increase the Earth's temperature. And then, of course, I mean, and if you know that all the major corporate houses are like, especially banks, they are aligning themselves to the Paris Agreement. So in every bank, I mean, I'm just saying this as a trivia. I mean, this might not be directly related to your buildings, but just to give you an idea how other sectors are taking climate change and the impacts of a increased global temperature seriously in their, and all banks in, well, under their risk management framework, they do a stress analysis. In that they do, okay, they as part of the risk management, that they see if tomorrow the global temperature goes up by 1.5 degrees Celsius or 2 degrees Celsius, how will that impact my operations, how will that impact my investments if I invest in a beautiful island nation in the real estate. And if tomorrow global warming does happen and the island is just flooded, more tsunamis, or sorry, not tsunami is not because of climate change, but more severe weather incidents, how will that affect my investments? So every sector, not only real estate, not only the energy, every sector is taking climate change very seriously. And then environment, social governance, this is, as you might know, This is a key performance index for the major corporate houses. For all listed companies, along with their annual report, have to come up with a sustainability report in which they have to declare their energy consumption, or say a water consumption, or a waste generation, or anything. So yeah, this is just to give you an idea of how the other sectors are treating climate change and the impacts of global warming on a global scale. And I mean, this is not in India. I mean, India, all top banks, ICICI, Yes Bank, and then Kotak, all they all have an annual sustainability report that comes out with their annual report for their stakeholders, for their investors, and everyone. So just to give you an idea on that. So just on top of that, so in India is also expected to add 3 billion square meter of new residential spaces by 2030. Now, I just want to say, by all means, if you have any question, please unmute yourself and stop me. There's no problem. You don't have to wait till the end of the session to ask questions. You can unmute and you can just speak up, not a problem. But by all means, please do ask questions if you have to. If you want to start any discussions, that is all good by me. We can make this more interactive, as much as interactive as we can. Right. So again, so apart from the commercial space, the residential space is also expected to grow quite big by 2030. Hence, as Yarena said, that that the Eco Samhita has been developed by the Bureau of Energy Efficiency. That was not done earlier, because earlier this ECBC was developed just for the commercial and sector. But seeing the rise of residential buildings and the amount of energy that is drawn by them, the Eco Samhita has also come up, right? So that is so you can see that how both the commercial and the residential sector has been uh, uh, given importance in terms of energy efficiency. Now, let's talk about the like how ECBC came to Yebin. So the first thing was uh, when this was part of the Eco 3 project. Now, if you know that the Energy Conservation Act that happened, I think, in 2001, that empowered the central government to prescribe ECBC code in the country. So under that, BEE and things were formed, and then BEE, in collaboration with the American with USAID, supported the development of Eco 2 project. And Eco 2 project, and the main uh, aim of that Eco 2 project was mostly capacity building for energy efficiency in the country. Now, under that, a committee of experts finalized the ECBC in consultation with stakeholders. When you say stakeholders, they say they went to all different types of say consultants, builders, and then government agencies, NGOs, and who not. And then they took their consultations in terms of what and how energy conservation building code should look like. And then based on that, in May 2007, ECBC was formally launched for its implementation in commercial buildings on a voluntary basis. That was the first thing. And then as per the EC Act, the central and then in 2007, BEE has been, since 2007, BEE has been actively involved in promoting ECBC awareness through nationwide workshops, capacity building for stakeholders. Holders. Now, when they started with this, they had three main aims. The first one was that they need to build capacity. By saying capacity, they means what they meant was capacity for knowledge. And then the second one was to build some model ECBC compliant projects within the country. Now, under the capacity building, they had two targets at that point. One was making people uh, as trainers. So all of us who are ECBCA master trainers, we were part of that objective. That said that okay, there was a figure at that time. I think 52 standards. I think we have at that time. We need to create X ECB number of well as part of that objectives. The second objective was training number of people through the ECBC master trainers who were trained in the code, right? So well, and then all these training sessions that are happening, they are part of that second objective. That means that all these training sessions, we go to different state ECBC cells, and then there is an invitation, and then the audience is mostly your representation from your local bodies, engineers, architects, consultants, right, architectural firms, MEP, your consultancy, all these people. So that was another. So the second KPI of the second objective was to conduct X num. Yes. Is there your question? Hello.
Hello, sir. Sir, your voice was cutting in middle.
Oh. Okay. Is it okay now?
Ah, yes, sir. Now it is fine.
Hello.
Hello, sir.
Okay. 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 Yes. Sure. Wait. Let me see. Where's the speaker of this thing? Anyways. Uh. So. As part of that second thing, what they said was we need to conduct X amount of training sessions. So that means ECBC trainers who were so we developed X number of ECBC trainers, and then they went and took X number of training sessions in various in various states to again to transfer that knowledge of ECBC to the grassroots level. So yeah, that was their second objective, right? And then the third objective, as part of this whole Eco 3 project, was to develop.
Hello, sir. Hello, sir. You are not audible.
Sir, no idea, sir.
Hello, sir. Sir, വിളിക്കുന്നു.
Hello, am I audible now?
Hello. Yes, sir.
Am I audible?
Yes, sir.
Okay, is it clear?
Now it's clear.
Okay. Sorry, sorry for that, audience. I think there was a glitch. I think my audio settings in the Go meeting was not rightly set. Um okay, can anyone say till what point I was audible and clear so that I can again start from there?
Echo 3 project, sir.
Okay, I mean Echo 3 project, which part? Okay, anyways, I'll briefly say that again.
Okay.
Uh,
Sir,
so
please share the screen again, sir.
yes. I'm sharing. Hello.
Okay, sir. We can see the presentation.
Okay, and also you can hear me.
Yes, sir.
Okay, great. So again, just to recap on the yes. Hello.
So you were
Sir,
you were
please
still at
continue.
the stage where you were saying that the second objective of the code to have ECBC trainers. Till that time it was clear. Thereafter it
Okay.
won't. Yeah. Thank
Okay. Sure. Thank you. Thank you so much for that. So yes, after the second objective was to take the ECBC code to the grassroots levels. So where us ECBC master trainers were taking X number of training sessions around the country, so that the knowledge of ECBC and yeah, how it is done, and then the EQS software, energy simulation. So yeah, that was part of the knowledge sharing or the transfer of your knowledge from the high level to the grassroots level happened. And then as a third objective, what they had at that time was we need to create X number of model ECBC projects around the country in various climatic zones. Right now, that was well, I was fortunate enough to be involved in a couple of those projects. So yeah, those were designed and planned in such a way uh, to be ECBC compliant. The construction, documentation, and everything, and then the final report, which I'll be sharing with you in the next or in the afternoon session. To show you what all details goes into the ECBC code. No, sorry, what all details go into the ECBC report. Now, yeah, those were again checked. Now, this entire thing was part of the United Nations Environment Program, right? So all those reports were checked by the UNEP officials to see whether uh, the actual aim of this entire investment that was done for the Eco 3 project meets its expectations or not. So all those things were part of the third objective. So that is how this entire ECBC, now what you see, I mean, now every state is either in process, or a lot of states have established rule, right, of a ECBC compliance, of a local building approvals having ECBC as a part of it. So so yeah, this all happened through a cascading through a cascading effect of these three objectives, which was first to train certain amount of people into the ECBC code to become trainers. The second is those trainers goes and take the training, and then transfer that knowledge to the grassroots level. And the third one was again creating these model buildings to see how much they work. I mean, whether on ground they are giving the expected output or not. So that was the whole objective of the CCBC, this Eco 3 project. So now I think, okay, okay. Yeah. So I think this slide is repeating. Now, if you see now, when ECBC started, as I said, they were targeted for the commercial sector. So any commercial building. So hence, the minimum threshold for a building to for the code to be applicable was a connected load of 100 kilowatt or greater, or a contract demand of 120 kVA, right, and are intended to be used for commercial purposes only. So private residential, even if their contract demand or say connected load exceeded 100 kilowatt, they were not part of the ECBC scope at that time, right? So hence, in the first part of the ECBC journey of India's ECBC journey, your residential was not part of it. Then slowly, residential became a huge energy demand space in the whole India energy market, and hence, and then they started the Eco Samhita process, and then it went on. Now, if you see now, as I said, now the different through ECBC, you can be either ECBC a building, ECBC plus building, or super ECBC a building. So these are the three levels of energy efficiency that you can achieve. So this, what we'll say now, when you say ECBC, now you have the three different classification of ECBC, ECBC plus and super ECBC. Now, what all systems do you need to uh, consider, and which systems or which building aspects do you need to consider to make them ECBC? So the first aspect is the building envelope. That is the exterior wall, the roof, the glass, right? The internal floor, ceiling, not that much impactful, but still it has very marginal impact on the entire energy performance of the building. If there is skylights, all those things form part of the building envelope. Even the underground, I mean, if there is a basement, the external wall of that basement, the slab on floor, so all those things form the part of the building envelope. Second is the control system. So all HVAC related stuff that so any system that is meant to create that comfort within the building, right? Your HVAC or heating, if it is there, like if your building is located in a very cold region, and then you need heating, so all those systems and how you control those systems to give you that comfort. So yeah, that is another aspect of the building that is there in the scope of ECBC, that ECBC controls to make your building compliant. Then the third is the lighting and your control. So your lighting again is a big part of your energy consumption of any building. Now, commercial spaces, it is even more important because in commercial spaces, you have a lighting that has to be on 24 hours a day, because those are either for security reasons or anything. Although ECBC exempts those kind of lighting that are there for emergency or security reasons. For example, if say there is any establishment, or say if there is a defense establishment, there ECBC cannot say that, okay, keep this much LPD to save energy, right? At that time, that is security, national security is a thing, and at that time, anything that is there for emergency and then security reasons, you cannot compromise on that. Similarly, in any buildings, or say in industrial buildings, any code that is applicable to industrial buildings, they do not generally do not include the process energy and the HVAC or the lighting that is required. If there is a factory where lighting, where high lux level is required, you cannot compromise on that, because if you compromise on that, some people may get injured, and stuff like that. So yeah, generally only so anything that is not emergency or that is not part of the process, that is not controlled by ECBC. But the general lighting, right, the decorative lighting, yeah, maybe, I mean, a lot of commercial spaces, they have decorative lighting and stuff. So all those things are there that needs to be controlled. So that also falls within the ECBC scope. Then the fourth one is the electrical and the renewable energy system. Now, electrical system, system refers to the transformer and the wiring and the losses and the feeder losses and all those things. And it also includes the renewable energy. So how much renewable energy, how you design your electrical systems in the building, that also falls within the scope of ECBC. Now, as I said, that there are certain aspects that are not touched by ECBC. So here, as you can see, plug loads, equipments, and parts of building that use energy for manufacturing process is not like you cannot apply ECBC on those, right, unless otherwise specified in the code. For example, if, as you can see in the screen, I mean, if there is a plug load and then you need security systems, say CCTV cameras and stuff, you cannot apply ECBC and say that, okay, we need the CCTV cameras to be controlled, it should be on and off. I mean, you cannot do that, right? So any plug loads, if equipments, and any load that is part of a manufacturing process, that is not covered by ECBC. Now, in terms of precedence, what precedence means, I mean, in case there is some conflict in between different codes, right? In between, say, there is some local municipal regulation and some part of ECBC is coinciding here with them, sorry, or is clashing with the requirements of the local code. So what takes more precedence? So as you can see here, any policy notified uh, as taking
Yeah.
precedence over this code. Hello, uh, any questions? I think I heard someone unmute their mic, and so is there any questions? Okay, I would take silence as a no. So again, so as you can say, that any policy notified as taking precedence over the code or any other rules on safety, security, health, or environment by central or local government. So any rule where there is a clashing aspect, any rules of safety, security, health, or environment by the central or local government, if that clashes with some of the requirements of ECBC, right, then those rules by the central and local government on safety, security, health, or environment will take precedence over ECBC, right? So just as an example, think if there is a, a local regulation saying that that we need to say increase or say something on a environment saying that this material needs to be used more, right? But then if you use that, you are not getting you value. I'm just thinking over the head. I mean, this might be a very bad example, but I think you can get the point. So any local government that on safety, security, health, or environment takes precedence over the CCBCA code. And then what is the second? The Bureau of Energy Efficiency Standards and Labeling for Appliances and Star Rating Programs, provided both or either are more stringent than the requirements of the year code. So if you are going for any BEE standard or labeling program or for the star rating program, right? So well, and you also have to say meet ECBC code, then the thing that is more stringent has to be year followed, right? So these are the precedents that anything that is notified by the central or local government on, well, on the four issues that is there in this slide takes precedence, and any BE standards or labeling or star rating programs, uh, whichever is the stringent, will take precedence over the other. So any questions so far? So just as a your question, has anyone come across any such issue while applying for ECBC your certificate, or say while submitting documentation? Anyone come across has had any experience on such conflicting guidelines? Okay, so I'll move forward. Yes. So as a reference standard, was what ECBC 2017 takes is the National Building Code 2016. Now this is the reference standard for lighting levels, heating, ventilation, HVAC, thermal comfort, air conditions, natural ventilation. So if you go through the ECBC 2017, at many points you will see that, for example, especially for the natural ventilation section, you will see that all the natural ventilation aspects needs to be as per NBC year 20 year 16. So the main reference for ECBC is NBC 2016. Now, under ECBC, there are various building classifications. Earlier, in the earlier versions of ECBC, building classifications were not yeah, part of the code, but I think in this they have added quite some building classifications. For example, if you see, so one is hospitality, so star hotel, no star hotel like lodging, dormitories, or no star hotels or your motels or your resorts. These are part of the hospitality. But again, when if you're building any of the hospitality thing, the main aspect to keep in mind is whether I meet the ECBC threshold or not, which is 100 kilowatt of connected load. If I am under that, I do not. So if I fall under that, if my load is not 100, if it is lesser than that, then I am not bound to to follow ECBC year 2017. Although I can do that on a voluntary year basis, but then that is the main year threshold, right? Again, your colleges, universities, institutions, schools, these are also are under the scope of ECBC, the 100 kilowatt threshold being the main reason. Now, if I am building a college or a school, again, all good. I can do it ECBC or a super ECBC or a ECBC plus. But again, I am not bound to do so if I am not. So if my connected load is not above 100 kilowatt, I cannot. So I am not bound to be ECBC compliant. Then again, healthcare is there. So hospital, outpatient healthcare. So yeah, these are also yeah, grouped under the healthcare. Shopping complexes, malls, standalone retails, open gallery malls, supermarkets. They are also classified under the ECBC. Then businesses, as you can see, that yeah, there are three classifications: large offices, medium offices, and small offices. So anything that is underneath of 10,000 square meter is considered as a small office. Anything from 10,000 square meter to 30,000 square meter is a medium office, and anything above 30,000 square meter is a large office. And then uh, if and then multiplexes, theaters, building used for transportation. Now these are used as assemblies. So yeah, there is some difference in the requirements for ECBC for these different type of buildings that we will see when we quickly skim through the ECBC code, right? That you will see. And as you have attended most of well, as most of you has attended uh, the okay, I think there is a Uh, yeah, question. Okay, as per EC Act, is it mandatory to go for ECBC rating for all buildings above? Yeah, see, EC Act was not the main binding thing. EC Act, I mean, the Energy Conservation Act gave the framework under which they created yeah, the BEE and everything, right? So it depends on the state. It is not a national wide thing, right? That it is, yeah, but it depends on the state rules, because under EC Act, and then every state has a thing. But it depends on every state, right? So, but in general, anything above 100 kilowatt in India is required to go for ECBC rating. Okay, now the next one is compliance approach. As you might know, that there are the main way of complying is to calculate the uh, the energy performance index ratio, EPI ratio, and then the EPI ratio should be less than 1 or equal to, and it should meet all the mandatory requirements mentioned in section 4.2, 5.2, 6.2, and 7.2, right? I think this is another one. I think 8.2 is also there. So what I will do is here, I will bring on the ECBC code here. I believe you can see the ECBC code. Can you see the code, or are you still seeing the presentation? Okay, so as you can see here, what it said, that all these sections of 4.2. So if you see this, okay, thanks for the conversion. So if you see 4.2 of every section, so 4.2, 5.2, here 6.2, and then 7.2, these are the mandatory requirements. So irrespective of whether you follow, now under ECBC, there are two ways of complying with ECBC standard. One is the whole building simulation method, and the second one is the prescriptive method, right? So if I so this is, I think I'll skip this. I think it's the next slide. Yeah. So to comply with the ECBC code, EPI shall be calculated based on one of the following. One is the prescriptive, and the second is the whole building simulation. So I believe you are aware of how whole building is done, and then what is it. And because so in whole building simulation, but I'll briefly touch on that. In whole building simulation, you have to run a energy simulation as per I think section 9 of the ECBC code, where you have to build a reference case as well as a proposed case, and then run the simulation as per the section 9. So I think section 9, it says, just before that, let me confirm. I think it's section yeah, section 9 is the whole building year performance year method. So section 9, so as per section 9, there it will say what all considerations you need to take for a reference case, and what all considerations you need to take for a proposed case. I mean, proposed case is what you have, right? What you are building, what glass you are using, what roof section you are having, what wall section you are having. That is your proposed case. What should be your base case? Section 9 of ECBC report, that gives you all those things. So I'll just quickly show you. So what this best part of this ECBC 2017 is, they have hyperlinked the sections. So if you go here, energy simulation requirements, right? Okay, so if I go here, say whole building mandatory requirements. So here, this table, right? This table point 9, which is the modeling requirements for calculating proposed ANYA standard. So this table will give you all the details of what a proposed your design should have, and what a standard your design should have. So for example, while you're developing the your model, say your eQuest, IS, or your whatnot, or your design builder. So here it says that the standard design shall be developed by modifying the proposed design as described in this here table, right? So everything in the proposed will be same until and unless there is a difference here. So for example, space use classification, that means how the different spaces will be classified, that should be same in the proposed and the baseline. Sorry, not here baseline. I'll use the term standard year design here. So everything should be, so the space use classification in the standard design should be same as the proposed year design. Similarly, So this table will show you, I mean, this is another good example. Under building envelope, what should be under your proposed design is there, right? What your standard design should be, it says the standard design shall have identical condition flows and identical exterior dimensions and orientation of the proposed, except noted in A, B, C, D, and E. So what does A says? That standard design performance shall be generated by simulating the building with an actual orientation and again rotating the entire building, 90, 180, 270, and then taking the average. Let me see if I can do a drawing tool. Okay, I'll just see if I can do a drawing tool. Wait. Mm, mm, okay, so for example, say this. Oops. So this is my building. This is say north, right, south, and then east, west. So if my building say is this is the original proposed case orientation. So in the proposed design, you will have to simulate it based on this. In the baseline, you do sorry, again, not baseline. In the standard design, you simulate it at this orientation, then you rotate this by 90 like this, and so you rotate it by 90, and then you do another simulation, and then again rotate it by 180, and then again rotate it by 270. So apart from that thing, you have to do 3 simulation. You don't have to change any other thing. You just rotate and you simulate and get the average value. So again, I mean, I just wanted to show you erase all drawing. Yeah. So that is how this ECBC code tells you what to do in the standard design and what to do in the proposed year design. So I'll again go back to this. So all right. So again, so 5.2, 4.2, 6.2, and 7.2, these are the mandatory requirements that whether you do a prescriptive or whether you do a whole building simulation, you have to do this, right? So yeah, that is one of the things, right? Now, based on how you want to do, you can go by prescriptive, you can go by simulation, right? Based on how you want to do, you have to calculate an EPI in both cases. In prescriptive also, you need to calculate. In whole building performance method also, you need to calculate. What the difference is, why you want to do a whole building simulation and a prescriptive. Whole building simulation gives you that option for adding diversity factors, for adding utilization profiles. I mean, for example, you cannot do that in the prescriptive. In the whole building simulation, you can tell the building that okay, from morning 8 to evening 6, my HVAC will be on by 70% of the total peak load, right? Maybe in the lunchtime from 1 to 2, it may be down to 50. All those variations you can make in the whole building simulation. If you're going, so that will give you a better picture of what the building will be when it is operational, right? So all those tweaks you can do in the whole building simulation. Prescriptive if yeah, method is a very straight cut thing. You just have to see, okay, this is my material, this is my exterior wall, okay, as per my calculation, the overall U value is coming this. I need to make my building ECBC plus for my climatic zone. It says, okay, well, I need to be 0.34. I am 0.32, hence I qualified. So it is just a checklist kind of a thing. Yes, this is done, this is done, this is done. Whereas whole building performance, it's a much more detailed and a much more organic and a lively way of complying with ECBC. But in both case, you have to calculate the EPI. Excuse me. So any questions so far? Am I being too fast? If you want me to again explain anything back, you can either type or you can unmute yourself and speak. Yes. Yes, thank you for your question. Yes, I was mute because I was expecting some questions and was just opening the mic up for the audience to speak. How to calculate EPI in the prescriptive? We'll come to that section. I will show you how the section where you can find and how I think it is written well written in both ECBC and the Kerala ECBC gazetted notification, right? So let me, as you say, let me bring that up then. So if you see here, I think the prescriptive method is where is it? Wait. Okay, I think I have that as one of the slides. Up till now, are there any other questions? I'll come to your question on the EPI calculation in the prescriptive. But let me know if there is any other questions from anyone else. Yeah, shall be gone. Okay, so yes, there's another question on that says, while calculation of EPI, shall we account yield from solar PV and consumption of EV? When you say EV, I believe you are mentioning electric vehicles. Is that what you're saying? Yes, EV charging. Okay. Yes. Yes. So you're right. While calculating EPI, especially in the energy in the whole building ye performance ye method, say you get the say X amount of, say, 100,000 kilowatt hour is required, is consumed by the building in the whole year, and you have the solar year PV. So what you will do is 100,000 minus the solar PV yield, that will be your net building energy ye consumption, right? So in the EPI, that will be accounted as well. So hence, when you do the ye EPI, in that case you will do the net energy consumption accounting for the PV yield divided by the total built up area. So that will be your energy performance index, right, in this. So you will consider that, but EV, no, we do not consider electric vehicle charge for this, because this, again, this will fall under process load. I mean, because if you have an electric car, you cannot no code can ask you to charge it less, and then be in problem halfway to your way to off. Yes. Sorry, is there a question? Is there a question? Okay, a follow-up is, in case of grid connected solar PV, is balancing the energy demand of the building and EV charging done from the same installation. Uh, so so are you trying to say that you're charging the electric vehicle from the solar PV directly, right?
Sir, can you hear me? I only
Yes,
posted the
yes,
question. Myself,
yes.
yeah. Sir, in normal nowadays in Kerala, the solar PV penetration is increasing. The government is also promoting it to a larger scale using some solar projects and all. So when installation, if it is consuming energy, it has a very good demand. So if he is installing a solar rooftop panel, which is a grid-tied system, can I say that the energy demand is decreasing, and is it correct, sir? From the energy conservation point of view, still the consumer is consuming that much energy. Say if it is 100 units is consuming, if he is offsetting it using 100 units generation from solar, still he is consuming 100 units, right? So how can we minus it? This is my first question. Second question is, in the same building, if he is using a electric scooter or electric car for his personal mobility means, so that is being charged from the same consumer using domestic tariff. So this will be creating additional demand, right? So that should be added to the energy consumption. This is my second question.
Yes, yes, I think those are two very valid things. See, I mean, offsetting energy, yeah, at the end of the day, offsetting energy, you're right. You cannot just, I mean, see, any thing is, you are not creating, what ideally you should do is you should first make your building energy efficient, right? Right. And then you are offset, and then you should offset, right? So I totally understand your point, whether you should install, say, so whether it is valid that you do not implement energy efficiency, but you offset the entire thing using a say a rooftop solar PV, right? So
Yes,
yeah,
yes.
that
I want to
is
know
what you're
whether
saying.
that is energy conservation. Is, yeah, whether that is energy conservation. Energy conservation means reduce the demand. So then only EPA
Yes.
will come down. Otherwise, if I consume higher and I am installing a solar PV to offset it, shall I take it upon to the EPA? Rather, we will take it to the carbon offset. Carbon offset, we can minus it since it is a clean energy. But while energy audit point of view, we are facing some we are requiring some clarifications in this matter. In the code also, it is not clear. That's
No,
why
see,
I
see,
asked this.
yeah, see, at the end of the day, what you see, I mean, either you do so say, in any ways, if you do this thing, if you do uh through whole building simulation only, right? If you do it through whole building simulation, right, you still have to meet the minimum requirements, right? So there is that basic level of there is that basic level of compliance which you have to make, right? So you cannot just make, say, just a single 120 brick wall and then have a huge solar APV on the roof, right? You cannot do, because at the end of the day, whether you go by prescriptive or whether you go by the whole building, right, you have to meet those mandatory requirements anyways, right? So your point is exactly right. That is offsetting carbon, not energy. That is totally right. But still, there are certain yeah, mandatory requirements that you have to meet, right? So yes, I think that, yeah, this is. I mean, you cannot. I mean, this does not say. If we go by, say, the CBC, where is it? This one, okay. Now, if I say, uh, okay, where is the whole building simulation? Yeah, simulation environment. Okay, this is whole building performance, mandatory requirements. Hmm. But if you go to see, I mean, in terms of, say, in the various green building rating systems that you have, right? They have two different. So if you go by ye Griha, they have energy efficiency as a different ye criteria, and they have renewable energy as a different criteria, just for the same reason that you said, right? That renewable energy should be X% of the total ye demand. That is the requirement, and energy efficiency should be the ye percentage stage reduction in yeah, in a solar. But a number of lead projects, they allow that renewable energy factor to be yeah, to be incorporated in the EPI calculation, right? And also it gives a number of, so in a way it is double counted generally, right? But that is the way. I'm just trying to uh, find the right uh, chapter, the section, to see if this is. Just bear with me for a moment. Mm, Simulation requirements. Yes, in this one. Lighting, match math. Yes. So as you can see in these requirements, The only requirement as per ECBC here is the service hot water. That's it. That the service hot water heating system shall be of the same type as the proposed design for residential facilities, hotels, and a standard design shall have solar hot water capable of of meeting 20% of the total water demand. Right. So you're right in saying that this does not exactly give that clear indication. Clear indication that whether renewable energy needs to be accounted in the EPI calculation, right? But just asking, I mean, in your submissions, has these been well, has this been an issue?
Yes, sir. Sir, in this case also, the solar hot
Mhm.
water, that is
Mhm.
also a consumption. So the energy demand for that consumption also has to be added to the EP, right?
Yeah. So for the solar hot water,
Solar is also
uh,
energy. Solar is also an energy.
yeah,
It
yeah,
is being consumed in the
yeah.
building. So we have to, we
Yes.
can reduce carbon, but we can add it to the numerator part of the EPA. And
Yes.
also one more thing, this if the instead of solar, if the consumer using a boiler or hot water boiler using diesel fired boiler, then the
Mm-hmm.
diesel consumption normalized to kilowatt hour, that can be also added to EPA. In the
Yeah, that
ECBC
can
code, I
be
think
added.
only electrical energy is considered. The thermal is not considered, right?
Yeah, but then you have to account for that only, na? You have to account for that in the in the calculation, because as you saw that in the baseline you have to consider that 20%. Say in your in your proposed case, you are having like 100% hot water generated by, say, a diesel, right? A thermal, right? uh, and
Yes,
but
yes.
in your proposed, you have to have x amount of you have to sorry, in your sorry, in your standard you have to account that my requirement is 100 liters a day or 200 liters a day, and then that has to be yeah, that has to be coming from 20% of that should be solar. So that calculation will anyways be in the denominator, right? That calculation will anyways be in the denominator. In the numerator, in that case, if you are not using any renewable based solar thing, I think then you will be at loss, right? But I think there is a certain percentage that is mandatory anyways. Right. I think, well, as this says, I think in the hot water yes section, service hot water, 20% of your building demand has to be met. I mean, that is a mandatory regulation under this. So if I go here and say, where is the hot water light control?
Yes, sir,
Yeah,
that is
service
right.
hot.
But in the numerator, whether it is electrical energy alone or thermal also will become. That is my question. That kilowatt hour per meter
You
square per
should
year.
consider
That,
I mean, you have to then find a conversion factor. You cannot add
that's what.
thermal
That's what.
energy
You
in there.
can
Yeah,
normalize to
yeah,
kilowatt hour, but the code I
yes,
think it is saying only electrical is to be taken. There's a lot of
yes. That
confusion
is
in between. So
no. See, at the end of the day, what code requires you to do is to give the actual thing. Now say if you're using thermal, right, you can always and then you can always convert that thing, saying that okay, if the same water I am needed to heat through an electrical, maybe the efficiency will change, right? Of course, the way the thermal works and the electricity, it will be a totally different efficiencies, and then you might come up with other, but then you have to consider that as a well in the numerator thing, right? So again, if you see here, it says that so hospitality and healthcare, right, has to provide 20% hot water of the design capacity and at least 40% of the design capacity uh, if the above grade floor area is above 20,000 square meter, right? And then exceptions, system that use heat recovery to provide hot water capacity. So your systems that use heat recovery uh, as per the type of the building. So if there is a heat recovery system that is used to provide hot water capacity, hot water, then you don't have to meet this requirement. But this is a mandatory requirement. But again, if you see here under heating equipment efficiency, you have the gas instantaneous. I mean, it is electrical as well as gas instantaneous water heaters, right? With a fuel efficiency of 80%. So if you want to go by the prescriptive way, you just have to meet this requirement, right? But if you're going through the whole building simulation way, there is a way you can incorporate in the eQuest software. You can incorporate a thermal component as well as an electrical component of the hot water heating system, right? I think Mr. Viplab will explain that later. I mean, you can raise this to him, and in the eQuest and other, you can say that, okay, I have a hot water service thing, and uh, this is the total capacity. This is a electric base. This is a say a heat recovery based, or this is a gas fired. All those things. So the software can account for that and give you the final calculation that ways, right? If you can do. But if you're doing it manually, a lot of people, what they do is they calculate just the energy consumption and then do separate calculations of hot water and add it to the energy consumption and that EPI formula, right? But you can incorporate whether it is a thermal or whether it is what. In that case, they will give you, I mean, in the eQuest output page, you will get it in terms of thermal and electrical separately if you're using a thermal based, right? So you did I answer your question?
Yes, sir. Yes, sir. Thank you, sir.
Oh, okay, thank you so much. More costly. Okay, I think you have a comment on this, that I feel SPV installation will be more costly than simple energy conservation. So client will first go to more energy efficient than SPV and try to, yes, that is absolutely fine. Yes, that is absolutely true. Because having SPV does not always mean I mean, it adds a lot of factor. I mean, again, your structurally, you need to have that much space on the roof of your roof to support that. So until and unless you're going for net zero kind of thing, right? I mean, yes, your comment is right. It is more costly. There's another question that is for DG also there are efficiency compliances in ECBC. Yes, that is true. DG set will be working for some equipment, so the energy consumption of that equipment is already accounted in the ECBC. So I think DG operation is already considered there. Yes. No, but I mean, DG consumption, you do not have to consider backups. I mean, we do not consider backup operations in our EPI calculation. So say if there is 3 chillers, two operational, one standby, we do not count for that. And just similarly, your DG set operations, yes, your DG set needs to meet the your minimum ECBC criteria. But in terms of the efficiency, I mean, yeah, that is only related to, I mean, at the end of the day, whether it is DG providing or whether it is the grid that is providing, the energy demand is still the same, right? The energy demand is still the same. So as uh, as Mr. Anish said that that you need to reduce your efficiency first by reducing the total building demand. So whether it is coming from DG or from the grid, that is the up end thing. You need to manage the demand side thing. So yes, there is a component of your DG in this, but still you will have to manage it. I think there was a question on how to calculate EPI through prescriptive. See what EPI through prescriptive, it says, so that means the building envelope trade-off method. This is how the EPI is sort of calculated under this, right? So this is so if you see section 13, I mean, this is the Kerala ECBC. So if you see section 13, it will give you the building envelope trade-off method. So yeah, this you will factor in all the EPFs, right? And then based on your climatic zones, sorry, just a moment. Just a moment, please. Yeah, sorry, yeah, for this. Yeah. There was a question, I think, on EPI ratio. Sorry, well, how is EPI calculated in the prescriptive case, right? So if you go to, say, this section, right, EPI ratios through prescriptive method. So section 3.2.21, it says that ECBC buildings that demonstrate compliance through prescriptive shall be deemed to have EPI equal to the standard building EPI, and therefore an EPI ratio of 1. ECBC plus and super ECBC that demonstrates compliance through the prescriptive shall be deemed to have an EPI ratio equal to the EPI ratios listed under 9.5, right? So that means the only calculation that you have to do in the prescriptive way is the building envelope trade-off method, right? So what you have to do is, first of all, apart from meeting the mandatory criteria, you have to meet the criteria of 4.3, 5.3, 5.3.12, and then lighting control 6.3 and 7.3 as well. And apart from that, you have to show compliance with this building prescriptive the building envelope trade-off method, right? Prescriptive criteria. So if we go to this one as per 4, yeah, this is how you calculate. I think this is, and the Kerala ECBC also gives the same thing. So you have to calculate the building trade-off method, the envelope performance factor here. So if you see uh, in this section, I think from page 68, they have given a clear a way, and the formulas have been written. They also give the various coefficient factors that you have to consider, and I think there is a application as well. Yeah, on this application of the building trade-off method, that is shown as an example for 100 square meter building, sorry, not 100, 1,000 square meter single story building. So this entire calculation is shown here. So in terms of the prescriptive method, your EPI is deemed to be 1 in terms of if you're doing just ECBC, and your EPI is considered to be, so if I bring this again, sorry, I think this is slideshow. So if I do this, yeah, so so this table 9.5, they give the EPI ratios for ECBC plus, and super ECBC based on the climatic region. So here, as you can see, for composite, these are the, so if you're going if you're going through the prescriptive, your EPI ratio, if you're going for ECBC, is considered to be 1. If you're going through prescriptive and you're aiming for the ECBC plus compliance, your EPI is deemed as 0.91, and for buildings that are going for super ECBC through prescriptive, their EPI is deemed as 0.81, given that the building trade-off method, this your baseline is higher than the proposed, right? This has to be now if you're not going the building trade-off method now, uh, uh, what, so I'll just quickly say what the building trade-off method is. Okay, there's another question, but section 9 is only WBP method. Yes. Mm, so, Mr. Basil, you had a question on this? I'm not clear on your question. You're right that section 9 is only for whole building year performance year method. That's true. But then these tables, 9.5 gives the EPI ratios. So if you're going through prescriptive, your hotel, if you're going for ECBC plus through prescriptive, your EPI for that will be deemed as 0.91. Now, in case you are not able to achieve these, I mean, if we go to say if I go to prescriptive requirements, say if you have a roof assembly, right? Say your region is a warm and a humid, you have a roof assembly, and due to so the table is not applicable for, no, it is applicable in a different way. So as we showed you, mm, Sorry. Yeah. So if you go to say determining EPI ratio in this prescriptive method, this one. So here, as it says that, well, as you can see, this thing, it says that ECBC buildings that are going through prescriptive shall be deemed to have equal. So say in any shall be deemed to have equal EPI to standard buildings, and therefore EPI ratios of 1. So all the, so say if you're going by prescriptive and in any of the forms or in any of the reports that you submit to the local body or the or the energy management cell, right? Uh, you have to write the EPI, and then if you meet the prescriptive compliance of ECBC, then you write EPI as 1. If you meet the prescriptive compliance for super ECBC for your hotel, then you write 0.91. So you're saying for calculating EPI, we need energy consumption for the building, which we won't be calculating. If yes, I totally agree. But ECBC is only giving you that option that if you're going by prescriptive way and if you are ECBC, then automatically without calculation your EPI is 1. If you're going for ECBC plus through prescriptive way, then automatically your EPI for your building is 0.91. You don't have to do the calculation until and unless you are doing a building envelope trade-off. So there's no calculation that is going into the EPI ratio for the prescriptive. It is just that if you meet the requirements of section 4.3, 5.3, 6.3, 7.3, if you meet those requirements, then your EPI will be considered as 1 for ECBC, 0.91 for ECBC plus, and 0.81 for ECBC, for super ECBC, right? Okay, yeah, thank you. So yes, so if we go, I'm sorry, somehow this is not showing me the time. It is 12:10. The first session is still 12:45, right? Wait, just
Yes, sir.
okay, yeah, okay. So I'll just take so I'll just quickly brief explain what the building trade-off method is, right? Uh, so building trade-off here method. So now. As you can see here, if you're going by the prescriptive way, in that case, ECBC says that, okay, you if you are say in a warm and humid region and you are a no-star hotel under 10,000 square meter of floor area, and then you have to meet 0.63 as your external wall U value. Now, for some reason, say, I mean, it can be say commercial purposes or some other reasons which is outside your control. You have you cannot meet this. You will have to make a wall that is not meeting 0.63. That is yeah, that means it is above 0.63. Then in that case you can compensate that through increasing some other or say you can compensate this by overperforming into some other aspects. That means roof or glass or say through shading or something. So in that case is where your building trade-off comes as, right? That is where your building trade-off comes here. So in that case where you're not able to meet all the prescriptive way, all the prescriptive requirements of the building envelope, roof, external wall, glass, or anything. I mean, glass is the most common thing that you find, that you do not have. I mean, glass, if you go from single glaze to say a double glaze, the cost goes up like anything, right? So in that, you can compensate that through some shading and all. So in that case, that you have to calculate the EPF total. Now in the EPF total, so you follow this entire procedure. A good example is also here given in this. So you follow this entire procedure and say, and you come to a EPF figure, right? You come to a EPF figure, right, using your proposed. So in this case also, you do a EPF like a performance, like an envelope performance factor for the proposed, and also do a environment performance factor for the baseline. And in this, if you're taking the building trade-off method, your envelope performance factor for the proposed must be below or less than the environmental performance factor of the baseline. So that means if you fail to reach, uh, like if you fail to comply any of the individual prescriptive criteria, just as I showed above, you cannot meet 0.63, then you do the calculation, and you have to prove that the EPF of your proposed is less than the EPF of the baseline. If you do this, then you comply for this part. And so yeah, that is the entire trade-off method that you have here. And this uh, uh, this yeah, 2017, you can refer from page 71. This gives you an example. This gives you all this shows all these steps that are there. So it is very easy to follow this and then come to the conclusion. This is the way that you have to show compliance through prescriptive way. Is there any questions up till now? I can imagine this can be a bit overwhelming, but if you go through this example, this is very clear. It is, I mean, each and every component has been calculated separately so that you understand, right? What you can do is just go through it and then see if there is any doubt on this calculation, right? And then if anyone has doubt on this calculation, we can take it up in the after lunch sessions, right? Okay, now coming to this. So as you can see now, as I now the main difference from this is this ECBC gives the requirement. So as you can see, it gives the requirement for all composite, hot and dry, warm and humid, temperate, and well, and the cold climate as well. Is now what the KS ECBC does is it gives you prescriptive requirements just for this state. So instead of having different, so here if I scroll up, say I go to the section there. Mm, yeah, yeah. So again, here there is only just warm and humid in here, right? So Kerala state is covered by warm and humid climate only. So in this case, you have to, for your meeting the Kerala state requirements, you have to meet just this value. So for any opaque wall, you have to meet 0.44 as a maximum U value ye factor for all 24 hours ye used building, and for ye daylight also, well, and for daytime use buildings also as a 0.44. Now, if you are unable to meet this, the same building trade-off method is given here in section K13, right? I think this document has been circulated with all of you, that shows which page the Kerala municipality building rules, what is there, right? But apart from that, this KSECBC gazetted notification, this is only on the energy conservation building code for the state, right? If you go to section 13, that gives you the building trade-off calculation, which is same. How to calculate that process you can get from the ECBC, because there a live example has been shown, right? So so again, as you can see now, the requirements are pretty much similar. It's just that as you can so if you see here also, just like the ECBC, the Kerala State Energy Conservation Building Code also says that the code is applicable to new buildings that have a connected load of 100 kilowatt or greater, or a contract demand of 120 kVA or greater. Okay, so yeah, there is a question, but ECBC is more stringent than KCBC. So Kerala buildings have to comply with ECBC values only. No, I mean for you, this is the gazette notification. So yeah, for the compliance, it is just no. But I think you're saying, wait, let me see. That is opaque. So if you see opaque assembly, so I think the yeah, the Kerala ECBC says as 0.44, right? So yes, you have to follow this one only. For you, it is the Kerala ECBC code only that you have to follow, because the rules are based on that only, right? So for you, the main thing to follow will be the Kerala ECBC code, right? And here also there is submission and all these things, that this we will come in the second session. I will tell you the process of the application, where to apply, what to apply, at what stage to apply, right? All these things come here. So this we'll show in the next session, right? Now as you can see, if you scheme through this, just like the ECBC, there are mandatory requirements as well as there are prescriptive requirements, right? So under 4.1, so 4.1.1, these are all mandatory requirements that you have to meet, right? These are service hot water, as you can see. I mean, the mandatory requirements here are alterations to building services. I mean, these mandatory requirements are a bit different from what the mandatory requirements are of the ECBC. But for you, these are the main things that you have to follow, right? Again, compliance approach, it gives the prescriptive method and the whole building performance method, right? Now in there, again, as I said, there is a envelope trade-off method that is there as well, right? That you have to meet. And similarly, there are mandatory requirements. So under every section, so if you see envelope, there is a set of mandatory requirements, as there was a set of mandatory requirements in the ECBC as well. There is a set of mandatory requirements for the U factor, for the SHGC, and then the exceptions are also there. And then similarly, just like that, there is the prescriptive way. Now, if you are going by the whole building simulation way, you are not bound to meet the prescriptive requirements, but the mandatory requirements of these sections you have to meet anyways, right? Again, this is for the warm and humid, so you have to meet these requirements for the approval process. Again, so yeah, these are again the prescriptive requirements. There is prescriptive requirements for the vertical fenestration. There is prescriptive requirements for the wall. There is prescriptive requirements for the roof as well, and then exemptions as well. So this table, I mean, this will, I believe, all of you have come across, have attended the sessions on the technical aspect. I mean, on the calculation of the SHGC and all, and then so I believe that you are aware of it, right? Uh, Again, these, and then similarly, again, as you can see, just like envelope, there is a heating section as well. I'll just use the drawing tool to be yeah. So yeah, there is the heating and air conditioning section, under which you have the mandatory requirements here, right? uh, mm, sorry. You have the mandatory requirements, under which, I mean, these are the various COPs and the IPLVs that are there. So for you, I mean, it is of a similar structure of what ECBC is, but at the base, the compliance methods are still the same. You either have prescriptive, you either have whole building simulation. If you are prescriptive, if you're going for the prescriptive, you have to follow these table here, up here, for the minimum VLT, or for the SHGC, or for the U value of the roof, glass, and wall. But if you're going for the whole building simulation, there is also, similar to the ECBBC, there is also a table here that shows the requirements for a standard design, and that shows the requirements of a standard design and the proposed design, right? And then you have to uh, go in the same pathway, the same compliance measure that is there, but the application process that we will be looking, we will be taking up in the second half of today's training session, where we'll also see a sample report. I have prepared a sample report to show you what all components you need to include in your ECBC report for approval process or for anything, right? And also we'll be showing you all the documentations that you have to submit to which body, so that the application process or the approval process are clear to you. So this is the basic one. Are there any questions so far? I'll open the floor to anyone who please feel free to unmute yourself and ask questions as well. Right. Can I take like a poll or something through this? I believe the earlier ones has had the option of taking polls, like of yes or no.
Sir, in this GoToMeeting, such a facility is not available.
Okay. Okay.
So those who have questions, please unmute and ask directly, or you please type it in chat box.
Yes, that would be fine as well. Or if there is anything that you want me to explain again. Okay, I will just show you this one. This is again as in the ECBC, section 11 here shows if you're going by the whole building simulation giveaway, just like ECBC, this also gives what should be considered in the proposed year building and what should be considered in the standard year design. Just like ECBC, again, all the system types, and then the chiller efficiency tables as per 6.1. I mean, this gives you all the things that you need to consider in your standard design. And of course, proposed is what you have, like, right? Proposed is your base things. So again, I mean, if you are doing your manual calculations or your building envelope, your wall constructions, this is how you should do it. I mean, this is the your typical your formula, right? And what okay, this is another interesting thing. This what you can on you do, that this table 12.4 of this Kerala ECBC guidelines, this gives you the standard conductivities of the building materials that you should use or you can use for your U value, your calculation and all. Generally, if you have say in a very concept stage of the year design, when things are working, you do not have the your materials and all these things you finalized, right? At that point of time, at that point of time, what you have to do is you don't know what materials you are using. So if you know, then you can get the brochures to the exact conductivity or the or the thermal properties. But if you don't know, you can use this table to use the conductivity values of different building materials in the calculation of your total U value of the of your envelope, right?
Excuse me, there is some
Yes.
disturbance in the audio. I think somebody's mic is on. If they can switch it off, it would be better. Or the admin can do that, please.
Yeah, thank you for raising this. Thank you. So I believe so. Just like as I said, so this gives the conductance factor for a number of your products, starting from glass fibers, you're starting from bricks and walls to your floor finishing, building membranes, insulating materials, right? Building boards. So you can refer to this table for taking the conductance values for your U value your calculation. That ways you have a good base of the figures of the numbers that you are you're taking, and always it is good to have reference of the values that you are taking for your calculation. So this one has been incorporated in the KS ECBC. See, and in the ECBC earlier year versions, it was not there, but yet they have incorporated this, and yet this is a good database from where you can take reference of your conductance values for the building materials. Mm, again, as I told you that there is the building envelope trade-off method is provided here. So if you're not able to meet any prescriptive way, you can come to section 13 and use this formula to calculate the EPF of the proposed and the EPF of the baseline, and your EPF of the proposed should always be lower than the EPF of the baseline. As you can see here, the reason, as you can see, why there is a single figure, because the state of Kerala, as per the 5 climatic zones, fall within the warm and humid, right? So hence the only the so only the U value and the building envelope requirements for warm and humid has been provided under this code. And then these are the various appendices which we will come across in the second half. I think if there isn't any other questions, we can end the session here. I think we are 10 minutes a bit early, but I think the session started earlier as well. But if there isn't any other question, if you have any other question, please feel free to ask. But if you do not have any, I think we can stop this session and we can reconvene at 2 o'clock. Rana, can we stop the session if there isn't any further question?
Oh, okay, sir. I think there are no. Okay, sir. Let us rejoin at 2 o'clock.
Okay, thank you so much. Thank you everyone. Again, thanks for attending the session, and thanks for all your questions. All of you. So all the questions raised were pretty valid and to the point, and I hope that I was able to answer your queries. Please, if you have any follow-up question, please communicate that to Yerena, and she can communicate that to me, and I can answer them. Thank you so much. Thank you.
Okay, sir.
Thank you.